Alright, what information have we been given? We've been given the fact that cobalt-3 carbonate is a powder, and being a powder, that means it must be a solid, so you know that's going to be a solid state. Reacts with sulfuric acid, acids are always aqueous, we can put that as AQ. To produce aqueous cobalt-3 sulfate, given as AQ, water, which is a liquid, and carbon dioxide gas, which is going to be a gas. So we know the states of our species in our reaction. The next thing is to figure out what are their actual formulas, because unless you get the formulas right, you're not going to get the balanced equation right. So cobalt-3 carbonate, if we think about that, it's told us that cobalt's got a valency of 3+, we know that carbonate's got a valency of 2-. If I cross them over, I'm going to get that cobalt-3 carbonate is cobalt with a 2 subscript, open a bracket, CO3 for the carbonate, 3, they told us it was a solid. That's the first species. It reacts with sulfuric acid. It's expected that Year 11s know that sulfuric acid is H2SO4 aqueous. And it's going to produce this aqueous cobalt-3 sulfate. So cobalt-3 sulfate, let's think about what that formula will be. Cobalt is 3+, sulfate is 2-, I cross them over, I get CO2, SO4, 3, so that's going to be CO2, open the bracket, SO4, 3, aqueous, plus it's going to be water, liquid, plus carbon dioxide gas. I'll just tie that up so it's not going to interfere with our results later on. So 3, and that was aqueous. So we've got the formula of all these species correct. Now it's balancing time, and balancing, we balance the metals first. I've got 2 cobalts. I can now leave the cobalts for the time being. Next thing I balance is my polyatomic ions. I've got 3 carbonates over here. Unfortunately, the carbonate has decomposed to carbon dioxide, so I can't balance the carbonates directly. But I can balance the sulfates. I've got 1 sulfate in the sulfuric acid, but I've got 3 sulfates in the cobalt-3 sulfate. To make 3 sulfates on both sides, I need 3 molecules of sulfuric acid. What I've got left now is carbon, hydrogen, and oxygen. So CHO, let's balance our carbons first. I've got 1 carbon in the carbonate, but I've actually got 3 carbonates in the compounds. That means 3 carbons in total. So I've actually got 3 carbons over here. That means I need 3 carbons over here. The way to do that is it must be making 3 carbon dioxide molecules. Let's look at our hydrogens now. In the hydrogens, there are 2 hydrogens in sulfuric acid, but I've got 3 sulfuric acids, which makes 6 hydrogens in total, which means I need 6 hydrogens over here in the water. The way to make 6 hydrogens there is if I had 3 water molecules. And let's see if I can remedy the mistake from last time. Now let's balance our oxygens. I have 3 oxygens inside each carbonate, but I have 3 carbonates, which makes 9 oxygens. I have 4 oxygens in every sulfuric acid molecule, but I've got 3 molecules. So that's 3 times 4, which makes 12 oxygens. Gives me a grand total of 21 oxygens on this side of the equation, which means I need 21 oxygens on this side of the equation as well. Let's see if we have that. We've currently got 4 in the sulfate, but there are 3 sulfates, so that gives me 12 oxygens in the cobalt-3 sulfate. I've got 1 oxygen in the water molecule, but I've got 3 water molecules, which gives me a total of 3 oxygens in the water. There are 2 oxygens in every carbon dioxide, but I've got 3 carbon dioxides, which gives me 6 oxygens in the carbon dioxide. So in total, 12 plus 3 plus 6 is 9 plus 12, which gives me 21 oxygens. So we can say now that 1 mole of solid cobalt-3 carbonate reacts with 3 moles of aqueous sulfuric acid to produce 1 mole of aqueous cobalt-3 sulfate plus 3 moles of liquid water plus 3 moles of gaseous carbon dioxide. And that hopefully will be enough to guide you through the last part of your assessment task, which I'm pretty sure is much easier than these examples.